Hi, welcome back to my class in Integral Calculus or Calculus 2. For today, we will take up the first technique of integration, known as integration by parts. The given is to find the integral of f of x dx. The integrand here is f of x. In integrating this by the technique integration by parts, we should be able to write the given integral of f of x dx as the product of u and dv. In the given integrand, you must decide which should be taken as u, and the remaining expression would be your dv. After you have decided which expression is to be used as u, we get the derivative of u with respect to x. U here is an expression that is a function of x because in our given, the integrand is a function of x. And when you decided that u is this expression as a function of x, then you get the derivative of u with respect to x. For the left-hand side, derivative of u is 1 multiplied by du. At the right-hand side is a function of x, so you get its derivative with respect to x, and you multiply its derivative by dx. The remaining expression would be dv. And after you have decided which expression is to be dv, you integrate both sides of this equation. The left-hand side with respect to v, that's why the integral of dv is v. And the right-hand side here is an expression, a function of x with dx. In dv is always an expression multiplied by dx. And you integrate the right-hand side with respect to x. Now, the given integral expressed as a product of u and dv is now equal to the product of uv minus the integral of v du. Take note of the direction. Integration by parts after writing the given integral as the product of u and dv is equal to uv minus the integral of v du. Now we take an example. We have the integral of x times cosine x dx. One of these factors, x or cosine x, should be taken as u, and the remaining expression with dx will be taken as dv. Now, suppose you have made a decision as to which expression is to be used as u, and then after writing this expression uv minus integral of v du, you find it difficult to integrate this. That's a clue that you must change your u or change your dv. For this expression, I will take x as u. U is equal to x, and we differentiate both sides. The left-hand side with respect to u, derivative of u is 1 multiplied by du equals derivative of x is 1 and multiply 1 by dx. So if u is equal to x, the remaining expression in the given integral, cosine dx, will be your dv. Again, if you take x as your u, the remaining expression in the given integral, cosine x dx, is your dv. Our dv is cosine x dx. Now, to get v here, we integrate the left-hand side with respect to v, and integrate the right-hand side with respect to x. The integral of dv is v. it's always b. The integral of dv is b. And here you recall the integral of trigonometric functions. The integral of cosine x dx is sine x. The integral of cosine x with respect to x is sine x. So the given integral is now equal to the product of UV, U multiplied by V, minus, it's always minus the integral of V du. V du equals U multiplied by V. U is x multiplied by V sine x. We have x multiplied by sine x. Minus the integral of V is sine x. V is sine x multiplied by du. V times du. Sine x multiplied by du is dx. You get sine x dx. And we have x sine x minus, from your past lessons on the integrals of trigonometric functions, the integral of sine x with respect to x is negative cosine x. Plus the constant of integration c. We simplify negative times negative is positive. The first term is the same, x sine x. Negative and negative is positive cosine x. Plus c. And that's the integral of x cosine x dx, x sine x plus cosine x plus c. Now, if you find it difficult to integrate this, then you must change your u or dv. Try to let u be equal to cosine x and dv equals x dx. That's the clue. If you have a difficulty, if you encounter difficulty in integrating this term, this integral of v du, then you must change your u. Either you change your u or change your dv, or interchange the two. We take more examples. For our second example, consider the following integral. We have the integral of ln x over x squared with respect to x. Again, we must decide which expression, a function of x, should be our u. In the given integrand, this is the integrand, you may let u be equal to 1 over x squared, or you may let u equals x squared, or you may let u equals ln x. And the remaining expression, including dx, will be your dv. If your choice doesn't work, then you must change your u or dv. For this given integral, I will take ln x as u. If this doesn't work, then we have to change our choice for u. So if u is equal to ln x, the remaining expression, which is dx over x squared, would be our dv. For u, we get the derivative of both sides. Derivative of u with respect to u is 1 multiplied by du. And from your course in differential calculus, the derivative of ln x with respect to x is 1 over x multiplied by dx. And from this equation, dv equals dv equals dx over x squared. We integrate both sides. The integral of dv with respect to v is v equals the integral of dx over x squared. And we apply the power rule to this integral, but first we bring x squared to the numerator and we take the opposite sign of the exponent of x. Hence, the right hand side is equal to the integral of, when you bring x squared to the numerator, you take the opposite sign of the exponent of x. So the exponent of x after you bring it to the numerator is negative 2. That's by property of exponent from your course in algebra. And we integrate this with respect to x. And by power rule, we add 1 to negative 2. Negative 2 plus 1 is negative 1. X to the negative 1. Divide by negative 1. Or v equals negative. Now we remove the negative exponent by taking x to the negative 1 to the denominator. So we have negative 1. If you bring x to the negative 1 in the denominator, the exponent of x becomes positive 1, x raised to 1, or simply x. Now, the given integral ln of x over x squared dx by integration by parts is equal to uv minus the integral of v du. And we substitute u multiplied by v. We have u ln x multiplied by v, negative 1 over x. We get negative ln x over x. Minus the integral of v multiplied by du. V is negative 1 over x multiplied by du 1 over x dx. Negative by positive is negative. 1 over x times 1 over x is 1 over x squared dx. We have negative ln x divide by x. Negative and negative is positive. Integral of 1 over x squared dx, or dx over x squared. But we have already found the integral of dx over x squared from here. The integral of dx over x squared is negative 1 over x. Negative ln x divided by x. And the integral of dx over x squared, integral of dx over x squared is negative 1 over x. Negative times positive is negative 1 over x plus the constant of integration, capital letter C. This is the integral of ln x over x squared with respect to x. Negative ln x over x minus 1 over x plus c. For our third example, we consider the integral of x times e to the x with respect to x. Again, we must decide our u and dv. For your u, an expression in x, you may use x or e to the x. If you take u equals x, then your dv is e to the x dx. If you let u be equal to e to the x, then your dv is x dx. I will take u equals e to the x. This means that the remaining expression x times dx is our dv. For this equation, we differentiate both sides. The left-hand side with respect to u, derivative of u is 1 multiplied by du. And the derivative of e to the x from your course in differential calculus is e to the x. Multiplied by dx. For this equation, we integrate both sides. The left-hand side we integrate with respect to v, and the integral of dv is v. And for the right-hand side, the integral of x dx, we apply the power rule. The exponent of x here is 1. Plus 1 is 2. We get x squared divided by 2. So the given integral is now equal to by integration by parts is equal to uv minus v du. And our u is e to the x multiplied by v x squared over 2. We get x squared times e to the x over 2. Our given integral of x e to the x dx is now equal to uv minus the integral of v du. Our u multiplied by v, u multiplied by v is x squared multiplied by e to the x divided by 2 minus the integral of v x squared over 2 multiplied by e to the x dx multiply minus the integral of v du. We have v x squared over 2 multiplied by du, x squared times e to the x divided by 2. X squared multiplied by e to the x divided by 2. And we integrate this with respect to x. But considering the integral of x squared e to the x over 2 with respect to x, you can see that this integral is now more complicated than the given. And this is what I was telling you earlier, that if you find it difficult to integrate the resulting integral of v du, then you must have made a mistake in the choice of u and dv, as in this example. So we will change our u and our dv. In this first attempt, we let u equals e to the x. Now I will take u be equal to x and see if we will have an easier integral v du that we can integrate easily. We let u be equal to x. If u is equal to x, then the remaining expression e to the x dx is our dv. For this equation, we differentiate both sides. The left-hand side with respect to u. Derivative of u with respect to u is 1 times du. And we differentiate x with respect to x. Derivative of x with respect to x is 1 multiplied by dx. And for this equation, we integrate both sides. We integrate the left-hand side with respect to v. And we integrate the right-hand side with respect to x. The integral of dv is v. And from your course in differential calculus, the integral of e to the x is e to the x. Now, this integral, the given integral x e to the x dx by integration by parts is now equal to uv minus, always minus the integral of v du. We substitute u multiplied by v. U is x multiplied by v e to the x. We get x e to the x. Minus the integral of v times du. V times du. E to the x times du is dx, integral of e to the x dx. Equals x e to the x. You now can see that this integral of v du, integral of e to the x dx, is much simpler than this integral when we let u equals e to the x. The first term is the same, x e to the x, minus the integral of e to the x with respect to x is e to the x, plus the constant of integration c. And this is the integral of x e to the x dx equals x e to the x minus e to the x plus c. We now find the integral of ln x by integration by parts. We only have one choice for u. It should be ln x. And our dv is the remaining factor in this integrand dx. We differentiate both sides. Derivative of u is du. And derivative of ln x from your course in differential calculus is 1 over x. And we multiply 1 over x by dx. For this equation, we integrate both sides. The left hand side we integrate with respect to v, and the right hand side we integrate with respect to x. The integral of dv is v, and the integral of dx is x. Now the given integral of ln x dx by integration by parts is equal to uv minus the integral of v du. Hence, the integral of ln x dx is equal to uv. U is ln x and v is x. We multiply x by ln x, we get x ln x. Minus the integral of v du, v is x, multiplied by du 1 over x dx. If you multiply x by 1 over x will cancel out and you simply get 1 multiplied by dx. Hence, the v times du, x times 1 over x dx is simply dx. The first term is the same, x ln x, minus the integral of dx is x. Plus the constant of integration c. Therefore, the integral of ln x dx, or the integral of ln x with respect to x is x ln x minus x plus c. In some problems involving integration, there are cases when you have to apply integration by parts more than once. And we take one such problem where we will use integration by parts twice. Consider the integral of x squared e to the 3x dx. We integrate this by parts and we choose an expression, the monomial x squared as our u. If our u is equal to x squared, then the expression e to the 3x dx will be our dv. For u equals x squared, we differentiate both sides. Derivative of u with respect to u is 1 and multiply 1 by du. At the right hand side, we have the derivative of x squared with respect to x. Derivative of x squared with respect to x is 2x and multiply 2x by dx. For this equation, we integrate both sides, the left hand side with respect to v. And the integral of dv is v. Since we integrated the left hand side, we also integrate the right hand side. But we integrate the right hand side with respect to x. But the exponent of e is not simply x. x has a coefficient of 3. So we must express this e to the 3x as e raised to a variable with coefficient of 1 by letting 3x be equal to w. We let 3x equals w and we differentiate both sides. Derivative of w with respect to w is 1 times dw. We are actually using simple substitution. Also get the derivative of 3x with respect to x. Derivative of 3x with respect to x is 3 multiplied by dx. And in the integral of e to the 3x dx, we must replace dx with an expression in terms of w. From this equation, we solve for dx. We divide both sides by 3. And 3 will cancel out from the right hand side. We have dx equals dw over 3. Hence, the integral of e to the 3x dx is equal to integral of e raised to w. 3x equals w. Multiply by dx, dx is dw over 3. Or b, 1 over 3 is a constant. Hence, by property of one of the integration rules, the integral of a constant times a function is equal to the constant 1 over 3 times the integral of the function integral of e to the w, e raised to w times dw. Or 1 over 3 is a constant, we can take that out of the integral sign. The integral of e raised to w times dw over 3 is 1 over 3 is equal to 1 over 3 times the integral of e raised to w with respect to w. Now we can get the integral of e raised to w with respect to w from your course in differential calculus. The integral of e raised to w is e raised to w. b now is equal to 1 over 3 times the integral of e raised to w is e raised to w. But w is equal to 3x. Thus, the integral of e raised to 3x dx is equal to 1 over 3 times e raised to 3x. Now, the given integral of x squared e to the 3x dx by integration by parts is now equal to uv minus the integral of v du. The integral now of x squared times e to the 3x with respect to x equals u multiplied by v. U is x squared multiplied by v 1/3 e to the 3x. We get 1/3 x squared times e to the 3x. uv is x squared multiplied by 1/3 e to the 3x is 1/3 x squared e to the 3x minus the integral of v 1/3 e to the 3x multiplied by du, and du is 2x dx. 2x multiplied by 1/3 e to the 3x is 2 times 1/3 is 2/3 x. X multiplied by e to the 3x dx. Again, this is the integral of v du, where v is 1/3 e to the 3x multiplied by du, 2x times dx. 2 times 1/3 is 2/3. X times e to the 3x is x e to the 3x multiplied by dx. But 2/3 is a constant, so you can take that out of the integral sign. The first term is the same. And it is in this integral of x e raised to 3x dx that we will again apply integration by parts, where we will take x as our u. And the remaining expression e to the 3x dx is our dv. Again, to this integral of x e to the 3x dx, we apply again integration by parts, where our u is x, then the remaining expression e to the 3x dx is our dv. From u equals x, we differentiate both sides. U with respect to u, its derivative is 1 times du. Equals derivative of x with respect to x is 1 multiplied by dx is dx. For this equation, dv equals e to the 3x dx, we integrate the left hand side with respect to v. And the integral of dv is v equals the integral of 3x dx. We integrate e to the 3x with respect to x. But we have already obtained the integral of e to the 3x dx. The integral of e to the 3x with respect to x we obtain by letting 3x be equal to w. And we get 1/3 e to the 3x. The integral of e to the 3x dx is equal to 1/3 e to the 3x. So we write here the integral of e to the 3x dx is 1/3 e to the 3x. So this now the integral of x squared e to the 3x dx is equal to 1/3 x squared e to the 3x minus 2/3 times the integral of x e to the 3x dx, which we will get by integration by parts. So we write 1/3 x squared e to the 3x minus 2/3 times the result of integrating integral of x e to the 3x dx by parts, integration by parts, the integral of x e to the 3x dx with u equals x and dv equals e to the 3x dx is equal to uv minus the integral of v du. Again, this expression is 1/3 x squared e to the 3x. That's the same 1/3 x squared e to the 3x minus 2/3, and we integrate x times e to the 3x dx by parts. So the integral of x e to the 3x dx by parts is uv minus the integral of v du, where u we let as x and dv, from which we obtain v is e to the 3x dx. We will now substitute u and v. U is x, v is 1/3 e to the 3x, and v du is 1/3 e to the 3x times du is x, and then we will integrate this term. We now substitute uv, or we multiply u and v, where u is equal to x and v equals 1/3 e to the 3x. We multiply uv. We have x multiplied by 1/3 e to the 3x is 1/3 x times e to the 3x. Minus the integral of v du, v times du. V is 1/3 e to the 3x and du is dx. We have 1/3 e to the 3x times dx is 1/3 e to the 3x dx. And we apply the distributive property of multiplication over addition or subtraction. We multiply each term by negative 2/3. The first term is as is 1/3 x squared. We have negative 2/3 multiplied by 1/3 is negative 2/9 x times e to the 3x. And negative times negative is positive. And 1/3 here is a constant. You can take this out of the integral sign. And you have 2/3 times 1/3 is 2/9. 2 over 9 times the integral of e to the 3x with respect to x. Now, what is left to do is to integrate e to the 3x dx. But we already found the integral of e to the 3x dx earlier during our first application of the integration by parts. We found that the integral of e to the 3x dx is equal to 1/3 e to the 3x. And we also use that in our second application of integration by parts. Here, the integral of e to the 3x dx is 1/3 e to the 3x. The first and second terms are the same. And we have 2 over 9 times the integral of e to the 3x dx is 1/3 e to the 3x. We multiply 1/3 by 2 over 9, that's 2 over 27 times e to the 3x. Plus the constant of integration. So the integral of the integral of x squared times e to the 3x with respect to x obtained by two successive applications of integration by parts is 1/3 x squared e to the 3x minus 2 over 9 x e to the 3x plus 2 over 27 times e to the 3x plus c. For your practice and assignment, please try the following exercises using integration by parts. For number 1, we have the integral of sine x over e to the x with respect to x dx. Again, by integration by parts, you must decide on u and dv. If after using your u and dv you find it difficult to continue, then you change your choice of u and dv. In number 2, we have the integral of x over e to the x dx. In number 3, we have x times the integral of x times sine of quantity 3x minus 2 dx. For sine of 3x minus 2, you have to make use of a change of variable. You have to let 3x minus 2 equals some variable. For number 4, we have the integral of x cosecant squared x dx. And from our past lesson with the integration of trigonometric functions, you would need the integral of cosecant x squared x dx. And try to look for the integral of cosecant squared x dx. In our past lesson, it is negative cotangent x. In number 5, we have the integral of x squared e to the x dx. In number 5, we have to apply integration by parts 2 times. And that completes our lesson for today on integration by parts. In the next lesson, we will take another technique for integration. If you have question about the lesson today, you ask your questions in the comments below. But don't forget to subscribe to my YouTube channel, Art Kalison, the channel of learning and leisure. Or you may ask your friends, your classmates, your neighbors, and relatives to subscribe to my YouTube channel, Art Kalison, so they may learn as well. Thank you for joining me in my class today in Integral Calculus.